All right. Good night, everyone. Welcome, everyone. Welcome back to another session. Welcome back to Manchester Institute of Learning Online Learning Hub. All right. I do recognize that I have some new students. Yes, I think I was hearing you, Finn. I do recognize that I have some new students. I want to take the opportunity to welcome you all. I hope you enjoy the class. I hope you enjoy the session. And most importantly, I hope that you will learn something tonight. All right. For the other persons who are in the class, rest assured, they will tell you that this is perhaps one of the most interactive learning platforms that you're going to experience. But the proof is in the eating of the pudding. So at the end, you can let me know what you think and join the family. For the persons who are new, all the classes are being recorded. Hence, you can get access to these recordings during the week, or sometimes, depending on my schedule, I might post them over the weekend. So whatever is taught tonight, in the event that whatever is taught you do not understand, or you need some clarity, or you need a watch over, you can access those via the YouTube link that is in the group to which you were added, and you can access those online lessons on the platform. Okay. All right. So for everybody else, good night. You know the usual routine. Let's dive right on in and get to the objective for tonight. Now, I believe on Monday we had discussed there's a new way how we're going to approach teaching. And if I stand corrected, if it is that I believe that we discussed and we agreed that on Monday we are going to teach mensuration, to which we started, and then we're going to go back to fundamentals on Wednesdays. Does that sound like what we agreed on, guys?
Yes, sir.
That sounds like what we agreed on.
Yes, sir.
All right, lovely, lovely. Guys, you can use up the chat, okay? If you don't want to talk to your microphone, you can just press the thumbs up so I can confirm that, everybody is in agreement with what we had decided on. All right. So you can use the chat, or you can use the reaction icon, the thumbs up or the thumbs down, or that kind of good stuff, okay? All right. I trust that everybody is in the session. Let me check how much persons are here. So we have approximately 44 persons, including myself, in attendance. All right. So hopefully, please, somebody can monitor the group just in case somebody else is in the group wanting to come in and I don't know. Please let me know. All right. Farah, thank you, Akila. Farah, I think your mic is unmuted, so I just don't want any sounds to come out. Okay. Lovely. All right. All right. So let's get right into it then, ladies and gentlemen. Trust that you can hear my audio and you can see my screen. So I'm going to go ahead and pull up the whiteboard. We are going to, of course, do a quick little recap on what we would have done in our last fundamental class. And in our last fundamental class, we would have discussed the order of operations. So let me just go ahead and try to see if I can grab that board. This was Monday night, so this would have perhaps been this board. Let's see if we can pull it up. Let's see if we can pull it up. All right, so for those who are just joining in, you will see on screen here, this is pretty much what we did. What you're seeing here on screen from let me just grab here. For those who are new, as I zoom up and move, right? These are the things that we did last week, pretty much, right? So we looked at operations with integers, right? And we did a bunch
Sir,
of
some
examples.
people are not in the screen.
Some people are not seeing this. Is everybody seeing the screen?
No, sir.
No, sir.
No, sir.
Okay, hold
I'm
on.
not seeing.
All right. Give me a second. So let me go ahead and exit and I will return. Give me a sec. Give me a minute. Okay, you're not seeing the screen. Just give me a second. All right, go ahead and confirm if you are seeing the screen now.
Yes,
sir.
sir.
Seeing
I'm
it.
seeing the screen.
All right, if you jump off again, please tell me. I'm not sure what's going on with Zoom. Tends to be a little bit shaky at times, but let's see here. All right, so for the new persons and persons who just need a little reminder, this is what we did last week, Monday. We looked at operations with integers. Then we went ahead and we looked at the order of operations, which is the rule of PEMDAS, right? So as you can see, I'm scrolling up. We looked at the parentheses, PEMDAS. We looked at a bunch of basic fundamental examples, and we looked at all the different things that we needed to do to get to the answer. And everything that you're seeing here on screen, there's a recording for this class that is available in the group. All right, so that's pretty much what we did. And I also placed a worksheet in the Google Classroom that you guys can get access to it. Okay, you guys can get access to the Google Classroom, right? I trust that. Oh, so the deadline was set for tonight, but I changed it today to Friday, so you guys have until Friday to upload. All right, to upload your answers so you can get an honest review based on your understanding of the topic. Okay. All right. So now we're gonna close this one, and then we're gonna all right. So we're gonna all right. So I'm gonna go ahead and open this one. Yes. So we're gonna keep our working out on this week. Tonight's topic, ladies and gentlemen.
If you're talking, sir, I'm not
We're
hearing
gonna
you.
be moving on to another going to be, and you can go ahead, guys, and head that up. So we're gonna be looking at approximation,
Sir,
guys.
yes, stop sharing.
My screen is not sharing. Okay. All right.
Sir, your screen gone.
Yeah. So I'm gonna go ahead and leave the room, and then I'll be right back because I think that's the issue. All right. So I think I should be okay now. I'm gonna go ahead and start the recording of the screen again. All right. All right, good. So you guys should be seeing the screen now. Hopefully it don't jump off again. Don't know what's going on with Zoom. But all right, here we go. All right. So trust that everybody's seeing the screen and hearing the audio. Let's get right into our objective for tonight. Okay. All right, ladies and gentlemen. Tonight we're going to be looking at the topic of approximation. So again, we're going to go ahead and we're going to grab a little notepad here. We're going to go ahead and start our note taking. All right. So tonight we are going to be looking at the topic of approximation. Approximation. Okay. Approximation. And as per usual, the most important thing to start a topic is to find out what is the meaning of approximation. What is the meaning of approximation and why do we approximate? What's the purpose of approximation? Now, in a nutshell, and in its simplest form, approximation, I'm going to type it on the screen, guys. Approximation is the method by which we reduce the amount of decimal places in a calculated value. All right, that's not a standard definition. If you were to go on Google or ask Siri or Meta, right, they're gonna give you something more mathematical. But in a nutshell and in the simplest form, and not to complicate anything, approximation is basically a method by which we're going to reduce the amount of decimal places, or we're going to size down the number to various forms, right? And the various forms that we're going to be sizing down the number to, here are the methods of approximation. One, you can be asked to round off a number to what is called the nearest whole number. The second one would have been where you can be asked to round off the number to a given number of decimal places, so decimal places. And then, of course, you may be asked to round off a number to a certain amount of significant figures. And I think that's where we're probably going to reach tonight. We're probably going to reach here. And then the last one is where we're going to pick up and close off next week's class and move into the next fundamental topic. We're going to be looking at what is known as standard form. Standard form. All right, the physics students will most likely know standard form with a different name. So standard form.
Excuse me, sir.
Sir,
And
your
then,
screen
of
is
course,
gone.
another name. Okay, I don't know what's going on with Zoom, but all right, I'm gonna come. So give me a second. Let me just type it and bring it back to the screen. Okay, standard form / scientific notation. Scientific notation. Now give me a sec, guys. I don't know what's going on with Zoom tonight. Your screen share ended. I missed it. You need to reboot the device if you cannot restart broadcasting to Zoom. Give me, let me see, guys. Give me 5 minutes, okay? I'm gonna restart my system. So I'll be right back. All right, guys, I am back, and I do hope that Zoom, them tell me some need to restart my device or reboot it, so hopefully it doesn't give me any more problems for tonight. Hopefully. All right, you see my screen, hear my voice, all is good to go.
Yes,
Yes,
sir.
sir.
All right, so hopefully now there is no issues. All right, so here we go. We're off to a really late start, but sometimes these things do happen. Okay. All right, so as we stated earlier, approximation, and it's loading, guys. Approximation is the method by which we reduce the amount of decimal places, or we're going to size down the number, right? We're going to size down the number, right? So something more concise, right? So I'm sure that maybe at some point during your life, while you're doing math or learning math, you would have done some sort of calculation and you end up with some weird numbers, some long numbers like 3.142986 for whatever reason, right? For example, there are some numbers in the world, right? That, for example, there are some numbers in the world that we consider to be very, very large. And there are some numbers that we consider in the world to be very, very small. And so writing those numbers on paper won't necessarily be something that you'd like to see. For example, if I were to ask you what is the speed of light, right? For those who do physics, you'll know that the answer is 3 times 10 to the power of 8. So therefore, we have something like 3 times 10. So give me a second. 3 times 10 to the power of 8. This literally means 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. No one wants to write such a number on the screen. Like, this is 3 billion meters per second. We don't really want that, right? Or let's say that we're looking at the diameter or the size of a human cell, right? You have some numbers like 0.00000017281. There's no, writing those numbers doesn't look attractive, so to speak. It doesn't look like something that you'd want to see on paper. So essentially then, the aim of approximation is to really size down or cut down the amount of digits that you're seeing, right? You're giving it it's not the most accurate answer, but you're giving it an answer that is close to its original value. So you're approximating it. A perfect example of what you guys refer to as approximation is like when you go into a store, right? And you look at the price tag of an item, right? And the price tag is something like $2,380. In your brain, what you do, is that you're not going to think like it's $2,380. You're going to say, oh, it's just 2005. So believe it or not, you guys do a lot of rounding off every day. Every day you round off, right? No one in real life actually talks the real figure. So let's say you're going to the supermarket and you want to buy, just a simple example, like a tin of mackerel, right? And the mackerel cost $155.68. You know what you guys do? Oh, it's about $200. You quickly round it off to the nearest whole number, right? So it's like you know that there's going to be change, but you don't really care about the change. All right. Another example where regularly approximation happens right in front of your very eyes. You guys often see Miss Chin do it. Until you go on supermarket, right? And you're watching the monitor. And let us say your bill come up to $2,350.88. They don't take $2,350 from you, they take $2,351 from you. So when they're accepting money from you, they tend to always round it up. And when you're getting back your change, then round it down. I'm not sure if you ever pay attention to that, right? So that is something that you guys must take in consideration, right? Approximation. You guys, as I tell you, every topic that I teach in this class, there is going to be a relatable experience to it. Once I teach you something, you have done it in real life, and I'm going to highlight it for you. All right. So hopefully that little nutshell explanation gives you an idea of what you are about to learn tonight. So essentially, like I said, approximation is the method by which we reduce the amount of decimal places in a particular calculated value. And there are 4 ways in which you can be asked to calculate. 1, the nearest whole number. 2, decimal places. 3, significant figures. And of course, 4, standard form. All right. So we're going to do all of that. Not in this class, but I think we're going to be able to do the first 3. All right. Now, what we're going to do now is that we're going to pull up another little notepad here, right? And in this notepad, I'm going to lay out the rules for approximation. So rules for approximation. So rules for approximation. Rules for approximation. All right, rules for approximation. All right, guys. So when it comes to the rules are pretty basic, right? And good news. I know you guys love good news when it comes to maths. Good news is that the rules that I'm about to give to you right now, these set of rules apply for the first 3 approximation technique. You use these rules for rounding off a number to the nearest whole number. You use the rules to round off a number to a certain amount of decimal places. And you also use the rule to apply to round off a number to a certain amount of significant figures. Standard form is a little bit of a different technique. We're going to talk about that next class. But for now, here are the rules that is applied when rounding off a particular number to the above methods. 1, the first thing that you need to do is to identify. You are going to identify the rounding position. All right. And when you go in the textbooks or you go on YouTube or you go on any other social sites, you have to understand they don't talk the way I'm talking. I'm literally taking the mathematics out of the explanation and just making the explanation sounds more language related, right? So when you go on YouTube, they're going to say you're going to identify the nth position, the nth position. An average person don't know what you mean by nth position, right? Especially if they're not really a math person or whatever the case is, right? So you're going to identify the rounding position. We're going to tell you what that means in a second. The rounding position. Once you've identified that, your second step is going to be, right? Your second step is going to be to check. It's a check process now. You're going to check the digit that appears after this position. So once you've identified where you want to round off the number, then you're going to look at the digit that comes after this position. Now, this is not a third step. This is a condition. So notice I'm going to use an asterisk here. 3 asterisks, right? And here's the asterisk. Let me see. I wonder if I could change the color of my writing. I don't know. Is there like a color thing here? It should be. Let me see. I wonder if I could change the color. That would be really nice. I don't see a change of color. I wanted a change of color. But anyways, all right. So here is the condition now. So after you've done step 1 and you've also done step 2, here's the condition. The condition is this number that you're looking at, if this number is greater than, right? So I'm going to use the symbol shortly. Greater than, this is the word, and I believe this is the symbol. Wait there. Let me see if I can find it. Greater than or equal to. Greater than or equal to. Oh, let's put it. Where's the equal sign? Okay, there we go. So greater than or equal to, I'm going to put this in a bracket so you know that this is the symbol for greater than or equal to. All right. So if this number is greater than or equal to 5, we will increase the digit before by 1. All right. Now we're going to put a comma here. Otherwise, we're going to use a transitional word here. So otherwise, if anything other than what I've just said, if anything else other than that happens, otherwise, come again, we will ignore. I'm going to put ignore in all caps so you understand that we're just going to ignore the digits after this line. All right? So that's the rule, right? Step 1, identify the rounding position. Step 2, check the digit that appears after this position. The condition comes in. If this number is greater than or equal to 5, we will increase the digit before by 1. Otherwise, if it's not equal to 5 or greater than 5, we're simply going to ignore the digits that comes after this position. Okay, Mr. Peart, I'm not quite understanding what you mean by this. I'm not quite understanding what you mean by rounding position and all that extra stuff. Give me an example, Mr. Peart. So all of this makes sense to me. No problem. Here we go. All right, so we're going to start off with some examples of rounding off to the nearest whole number. All right, so pay close attention, guys. I'm going to keep the rules on the screen so you can see that I'm following the rules and not breaking them. All right, so here we go. We're going to start off with rounding off to the nearest whole. Let me just title it up here. Nearest, N-E-A-R-E-A-S, N-E-A-R-E, sorry, N-E-A-R-E-S-T, nearest whole. All right, so here's some examples. Number 1, let's say that you are given the number 34.15. No, sorry, I'm so sorry, guys. I want a better number. So 34 point, I hope you can see that point, guys. Can you see that point? And put it brighter. Point, can you see? Okay, perfect. So 34.76, right? And the instruction is to round this off to the nearest whole. So round this off to the nearest whole. So what do? I'm going to grab my yellow marker here, right? And I need to identify where is the last digit that makes the whole number. Now, every whole number ends at the point, guys. Every whole number ends at the point. So for whole numbers, you're always going to draw the line right through the point right here. All right? So what that line does is that you've identified the rounding position, meaning that's where I want to split my number. I'm going to decide if I want to keep the 76 or I'm going to increase, sorry, I want to decide if I'm supposed to keep the 34 or am I supposed to increase the 34 to 35. In order for you to know whether to increase the 34 to 35 or leave the 35 but 34 alone, you're going to check the digit that comes right after that line. Now, here's here, check the digit that appears after this position, which I've done. So checking it now. What have I checked? What's the condition? Did it meet the condition? The condition says what now? If the number that you're looking at is greater than or equal to 5, you're going to increase the digit before by 1. So I'm going to therefore essentially just add 1 to the 4 right here. And so my final answer is going to be 35. So I've rounded the number 34.76 to the nearest whole number. So my answer then there is 35. All right? Lovely. Let's do another example. Let us erase here and ensure that we are following the rules. All right. Now, let us go up here to another example. Okay. All right. So let me just move, let me just go a little bit. Okay, here we go. Lovely. All right. So I can keep the rules in the site, in the frame. Okay. So let's say that we end up with a number like 126 point. Oh, that's not a point. That's such an ugly point. Okay. Nope, that's not a good point either. Much better. Not great, but better. All right. So 126 point, let's do 381. All right. And again, the instruction is the same. We want to round this number off to the nearest whole. I do apologize for my atrocious handwriting, guys, but I guess you understand what I mean. All right. So the nearest whole. Once again, the whole number stops at the point. anything that comes after the point is called a decimal place. Anything that comes before the decimal point is known as whole number position, like hundreds, tens, thousands, right? Like that. So once again, I'm going to draw my line right here, okay? I'm then going to go ahead and check the digit that comes right after that number. Now, did it meet the condition? What's the condition? The condition is if the number you're looking at is greater than or equal to 5, you're going to increase the digit before. Here comes the otherwise. This is the otherwise because the number you're looking at is not equal to 5, it's not greater than 5. That means it falls under the otherwise condition. Therefore, otherwise, I'm going to what? Ignore these. So my final answer is going to be 126. And that's rounding off. Yes? All right. So hopefully you guys are following and you are understanding. Let's go again and look at another example. Okay. So now let's say that we end up with something like up here, example number 3, guys. 5. I don't want to remove it from the frame. That's doing it like that. Okay. So 5.5. That's a point. Okay. 5.581. Right. And the same instruction, guys. You're gonna round this out to the nearest whole numbers. NE. Oh Lord, space is no good. Okay, guys, hold on. Okay, here we go. Get that out of the way. So now we're going to go ahead and we are going to try to round this off to the nearest NEAREST whole. ST, pardon me, whole. All right. So 5.58.
Sir, unable to hear or see your screen.
Sir, I'm not hearing you.
I hope nobody lost me. Guys, did you lose me at the last part?
Yes, sir.
Yes,
Like the
sir.
very, very last part, you heard everything up to the last example?
Yes, sir.
Yes, sir.
Okay, so that means the only part that you would not have heard.
Sir, I'm not hearing anything that you're saying, and your screen is gone.
All right, you hear me now?
Yes, sir.
Right, so I'm saying that, did you hear me up to the last part? Did you see the last example? Abigail says yes. Let me see the
Yes,
thumbs up in the
sir.
chat. Oriana, Sasha, Sash Monique, Simonia. Alicia. So everybody heard me up to the last section. So
Sir
that
Pierre?
means you would have seen where
Sir Pierre?
Yes, go ahead.
Yes, for me, I didn't
Yes, go ahead. I'm
hear
hearing.
the last example. The fifth day
That
what?
last part there, 5.581.
I need you to go back over that one because we never hear you right there.
Okay, all right, good. All right, good. So I figured more or less. So, okay, then we are right here. So we have the number 5.581. Again, just like the two previous examples, we're going to draw the line right between the 5 and the 5 because the whole number stops. Whole number stops at the point. We draw the vertical line there, check the number that comes after. As you can see here, that is 5. It's not greater than 5. It's not less than 5. However, if it's greater than or equal to 5, you're going to treat it as if it was greater than 5. Hence, it's that plus 1 I have above the 5 there. We're going to add it to get 6. Therefore, the round off value is 6. Everybody's clear?
Yes, sir.
All right. How's the chat looking? Thumbs up, thumbs up. Thumbs up, thumbs up, thumbs up, thumbs up. Yes, everybody seems to be happy. Floating thumbs up fingers going all around. Fantastic. Lovely. Perfecto. Nice. Good. So now we got rid of that. So now you understand the basic application of. Now you understand the basic application of the rounding off rules. And like I said, the rounding off rules for whole numbers is the same thing as the rounding off rules for significant figures, and it's for decimal place. So we're going to move right into decimal places then. All right, we're going to look at the example. Now, as my screen or my whiteboard is loading right now. Okay, so it's finished loading. All right. Is there someone in the group that wants to get into the class? Because I see my device keeps going off. Is there someone in the chat or someone in the group that wants to come on?
No, sir.
Okay, I don't see. I don't see some other person. Okay, because you shouldn't be. All right, lovely. All right, so now that we are clear on that, let us move to decimal places then. So is there a... Why is somebody... Oh, these persons are... All right, here we go. I do apologize for the persons are actually calling me while I'm teaching, which is, I just don't understand why. All right, here we go. So now, decimal places, let's move on here. Decimal places. Now, it gets a little confusing. Believe it or not, for some persons, it does get a little confusing, right? Where they... Just a minute, guys. Okay. Are you guys still seeing the screen?
No, sir.
No, sir.
I don't know. Zoom is just getting crazy right now. It keeps kicking me off the screen, but I'm going to continue trying, guys. I do forgive me for the quality of the stream. Don't know why it keeps doing that. All right, so just keep me posted if you're not seeing the screen, okay? Just please just say it, and then we just try to pull it back again. All right, so in the meantime, while the board is loading, and if you are seeing the screen, then decimal places, it does get a little confusing for some people. For some people, it does get a little confusing because they tend to be like, they're not quite sure what decimal places is. So here's what decimal places, guys. It's self-explanatory. It is all the places that comes after the point. So our focus is never going to be on the digits that comes before the point. That means when you hear about 1 dp or 2 dp or 3 dp, it is really essentially talking about the digits that comes after the point. So when I give you a number and I say, hey, we're going to round off this number to a given number of decimal places, it means that I want to reduce the amount of digits that appears behind the point or after the point. So remember, approximation is essentially reducing digits. That's what we're doing. Approximation, remember the definition, guys, don't lose it. Approximation is essentially reducing the amount of digits that appears behind the point. So if that's what we're trying to do, if we are essentially trying to reduce the amount of digits that is in the number, then it means that by logical reasoning, rounding off a number to a certain amount of decimal places means that you're trying to reduce the amount of digits that appears behind the point. Now again, like I told you, once you're in this class, you're going to understand why you do the math, why we are doing the math that we're doing. Where do we do these things? In real life, guys, right? In real life, the highest number of decimal places that you're ever going to have to deal with is 2. Is there anybody here that can give me an example of a decimal place value that we use every single day?
Sir,
Yes, go ahead.
cents, sir.
Very good. Cents, money. When you go into the store and you purchase something, there is decimal numbers all over in the supermarket. If you notice that everything in the supermarket has dollars, cents. A tin of mackerel, a tin of sardine, a bag of rice, a bag of sugar, whatever you want to buy. Even if you want to go into the store, certain stores, they don't give you flat figures. And if they do, they're going to say $2,350 and 0 cents. But in the supermarket, it's a typical example of where approximation is done daily, actively. And like I said earlier, when you're rounding off, so in the supermarket, the attendant or the cashier or Miss China or whatever you want to call her, right? She rounds up when she collect your money. But when she's giving you your change, she rounds it down, right? For example, perfect example. You buy something for $55. Sorry. So you buy something for $51.56. You cannot give her $51, She's going to say what? The money short. Because she round it up and say 52. But look at it. You see, if the change comes out on the screen to be $51.55, you think she's going to give you $52? Nope. She's going to give you 51. So perfect example where rounding off takes place in your very eyes every day. So now look at it now. For these examples, there is no reason for me to ask you to round off a number to 3dp, because that would technically defeat the purpose of why I want you to round off. Essentially, I don't really want to see so many decimal places behind the point. What I want to see is a limited amount of decimal places. So the maximum decimal place that I'd like to see is 2, and the minimum that I would like to see is 1. Let's get into the example. And remember, the rules remain the same. Now we have a number like 55.2716. And the instruction is that we want to round this off to 1 dp. 1 decimal place. That's the instruction. So we want to round off this number to 1 decimal place. I need to figure out where or which digit holds the first decimal position. Then I'm going to grab my red bar and I'm going to draw my line right here, because the number 2 holds the first decimal position. Then we're going to go ahead and apply the rule. Boom. This number is once again greater than 5. So therefore, that means that we're going to increase 2 by 1. Therefore, our final answer is going to be 55.3. That's your answer. Not true? All right, let's do another example. Let's do something then. Hopefully you guys are clear. If you're not, you just use the microphone and let me know to slow down, okay? Because sometimes I do get into my element and forget that I'm actually teaching people and not teaching myself. So Remind me to slow down if I'm going a tad too fast, okay? All right, let's go. We have 123.256. And I want to round this off once again to 2dp. I want only. So basically what we're looking for is essentially, I want to see one digit behind the point. This time I want to see 2 digits behind the point. At the moment, I'm seeing 3. So I need to decide that, do I get rid of the 6? Do I ignore the 6? Or does the 6 cause the 25 to increase to 26? I don't know. Let's find out. So once again, sorry, I don't want this to happen. I don't want this to be a 6. My apologies, guys. I want this number to be like a 3. Right. Okay, here we go. So 123.253, I'm draw the line right at 5. Sir, why you draw the line between 5 and 3? Because the number 5 or the digit 5 is in the second decimal position. So I draw the line here. Check the number that comes after. This number is what? Less than 5. So what's the rule when it's less than? It falls in the otherwise condition. So I simply just ignore the 3 like it wasn't there. So my final answer is 123.25. There you go. That's your answer. All right. All right. That was a pause to see if there's anybody who wanted to take on the floor. Nobody wants to take on the floor. Everybody seems to be okay. Let's do another example, right? I want to make sure that we do as much example where no matter which question you get, you'll be able to always come back to this video or this recording or come back to the document and follow the example. Let's see here. Let's say we have something like 9.4516. And I want to again round this off to 1dp. Notice all my examples are going to be 1dp, 2dp. Unless I need to emphasize a specific point, I might just say 3dp, but it's very rare that I'm going to say round off to 3dp. What may do with some decimal digits behind the point? It's too much, okay? All right, so we have 9.4516. I need to find out which digit holds the first decimal position, and that's going to be the 4. Draw my line here. Check the digit that comes after. Now, the digit that comes after, okay, it is not greater than 5. It is not equal to 5. It is, in fact, sorry, it's not less than 5. It's not greater than 5, but it's equal to 5. So again, this falls into the otherwise condition where, sorry, it doesn't fall in the otherwise condition. I'm so sorry. It's not greater than 5, but as long as it's equal to 5, you're going to treat it as if it was greater than 5. Hence, you're going to add 1 to this little digit 4 right here. You're going to end up with 9.5. All right? So please let me know in the chat, guys, using the reaction. Are you guys understanding? Are there any questions? Let me see some thumbs up or thumbs down. Lovely. I should be seeing a flood of thumbs up, you know. Lovely. Beautiful. Love that. Lovely, 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 lovely. Excellent. All right. And I trust that all those persons, I should be seeing at least 40 thumbs up because like 44 of us in here. All right. Okay. Lovely. All right. Fantastic. Nice. So let's move right along to another. Now, in everything, there's always going to be a little trick, a little twist, a little, you know, one of those questions that you get it wrong and you wonder, how? I swear, I saw Mr. Pierre teach this in the class and I understand 100%. And how me get this wrong? Here's a question that will sometimes give you that feeling that you don't like. Here's this question. Say we have 23.9841. Then Mr. Peart, there is nothing special about this number. It looked like the rest of them. So what makes this question so tricky? All right, let me show you why it's tricky, right? Let me show you why it's tricky. So it's tricky because you have to be very careful with this 9 right here. This 9 is a problem, All right. So we're going to go ahead and I'm going to round this off to 1 dp. All right, 1 dp. So which digit holds the first decimal position? Obviously, it's the 9. Draw the line here. Check the digit that comes after. That digit obviously is greater than 5. So we're going to increase 9 to, I bet what's coming out of your mouth right now is we're going to increase it to what? 10. Not true? And then you go write 23.10, leave the exam, mash up the exam. When you come back, incorrect. How? If you add 1 to 9, I get 10. Naturally. Here's a fun fact, and something that you didn't even know that you know. There is no such number as 10 in our number system, right? There are 10 digits in our number system, runs from 0 to 9. So when you add 1 to 9, you get 10, but you have to go back a 0. In other words, then, when you add 1 to 9, you're going to get 10, right? I'm going to zoom up for you here. Watch this now. I'm going to zoom up right, Sophia, right? So when you add 1 to 9, you get 10. I agree. So see that 10 here now? Boom. You see that 0 here? It's going to replace the 9. That 0 here, it's going to replace the 9. This 0 here is going to replace the 9. I don't know what's going on with my, okay. This 0 is going to replace the 9, and then you're going to add 1 to this here and make it 24. All right? So the 0 on the 10, right? You're going to, okay, give me a second, guys. I think my device is freezing once again. Okay. Give me a second, guys. You can see that my device is really freezing. Give me a sec. Once the device is too hot, then or it's really warm, it tends to always freeze up a little bit. So forgive me for that glitch. Okay. All right. Should be okay now. So you might look at this and be like, okay, so this is a little tricky. This is a little complicated. It really isn't, right? I'm going to show you a way how you can eliminate that complication. Okay. Let's zoom up back here to what we were doing earlier. So here we go. We're coming up on the screen, right? So this is where we were. We were saying then, come again, ready again. So we say we're going to go ahead then and we're going to increase. So we draw the line between the 9 and the 8. The 8 is greater than 5. We add 1 to 9, we get 10. So you see that 10 there, you can't just replace the 9 with 10, you know, because 23.10 is too far from 23.98. It's too far. That's too much. That's too much approximation. So what you're going to do is that you're going to replace the 9 with the 0 that's on the 10 and add the 1 to 23 to get 24. So I mean, I understand that. That was confusing. All right. Here's what you're going to do. Is instead of you add 1 to 9, watch the style here. You're going to just add 1 to 39. Blows and skirts, sir. And what you're going to get? 40. So you're going to get 24.0. Sick alive? Jesus. Yes, that's what you do. So yes, when you're adding 1 to 9 and you get 10 and you're not sure, instead of adding 1 to the digit before, you're just going to just add what? 1 to. So you're going to look at 3.9 as 39. And you just add 1 to 39, you get 40. So you're going to get 2 and the 40. So the answer runs off to 24.0. So do I have to write the 0? Not necessarily, because if you don't write the 0, then it's going to be assumed that there's a 0. But like I said, guys, I'm going to put yourself in extra problem and extra stuff. If them say 1 dp, just write the 1 dp. You see me? All right. Let me see some thumbs up or thumbs down. I feel like I'm supposed to see some thumbs down for this one.
Excuse me.
Yes, go ahead.
I understand the 1 dp. What if it's 2 dp? Can you show me an example with that same question?
For that same example?
Yeah.
All right. So I'm seeing the thumbs up. I didn't see any thumbs down a while ago. That's really good. Wow. Okay. I was kind of anticipating some thumbs down, but okay. All right. Good question, my dear. Let us look at 1 with a 2 dp. Same procedure. So let's say we have 38.996 6, 3, and we want to round this off to 2dp. Very good question, right? The principle remains the same. Which digit holds the second dp position? Boom, right there. So not true. Go ahead, check the digit that comes after. That's a 6. 6 is greater than 5. So my friend, instead of adding 1 to 9, you get 10, and then carrying the 1 and put on the 0, and then adding that to that, and it's too much. All you're going to do is just increase 99 to what? 100. You can't write down 100, so you know. You're going to replace the 2 9s with the 0 and carry the 1 all the way over here, and you're going to get 39.00. All right? So just in case, that was a really good question. That was a really good question. So basically then, right? If you want to look at it from a broader point of view, then you basically increase 3,899 all the way to 3,900, if you want to look at it that way. All right? So if you don't want to look at it from a digit point of view, look at it from a huge number point of view. So you can either increase 99 to 100, or increase 899 to 900, or increase 3,899 to 3,900. Essentially, you're going to get the same thing. All right? So again, that's second example, brilliant question by that student. Let me see the thumbs up. Who get the concept? I'm anticipating some thumbs down. I'm not seeing a thumbs down. I'll be a thumbs up, me and see. I was thinking I was going to see some thumbs down.
I have a question, sir.
All right, go right ahead. I'd love to hear this one.
Okay, so regardless, all the example that we done on the decimal places, does the value on the right changes? Does
Yes.
the value on the right changes when you're making the line?
When you say the value on the right,
does it change?
So look at, I'm so sorry. Look at the screen and tell me what the value on the right changes. Be specific.
All right, for instance,
what change? Like the 9963?
No, 63.
Go ahead, I'm listening.
Yeah, so I'm looking at the 63.
As in you want me to write it on the screen?
All right.
If it changes, no, we just ignore those. We just ignore them.
Okay.
They're irrelevant right at this point, because essentially approximation is to try to get rid of much of them as possible.
Okay.
So we had 4 and we only needed to see 2. So 6 and 3 is just out there. All right?
Okay.
Lovely. All right. So we've been through all the little tweaks. So then I'm going to try twist up, right? Try twist you up. Try, make you get the little 1 mark question wrong. Not in my cabinet. We can't try that with you. Okay? So we've covered that. Now, 8:14. So we're after a late start. We never want to speed up that part here. But anyways, let us get into... So we've done all the examples for significant figures then. Sorry, for decimal places, right? I realize that the rules are the same. It's just that with the decimal places, the focus is on the digits that comes after the point. With the whole numbers, the digits are before the point. So one focuses on the digits before the point. The other one focuses on the digits after the point. Can anybody guess what this one's going to be focusing on? Remember, me just give a clue, The first one focuses on the digits that comes what? Before the point. The second one focuses on the digits that comes after the point. What do you think the third one I go focus on? Both before and after the point. All right. So I have a question for you. All right. I have a question for you. Here's the question then. I need to hear somebody speak to the microphone. Big question. Big question. Does, I hope nobody minds if we go past 8:30, because we had some glitch with Zoom and that and this and after a late start. So I hope nobody doesn't mind if we go until 8:45, because we don't want to leave tonight. We don't want to rush this, but I don't want to leave without going through it, right? Because essentially we'd have not achieved the objective for tonight. So the question is, does 0 have a value? Go in the chat. I need to see some person say yes or no. We're heading into the chat. Does 0 have, don't use the share icon, use the chat. Does 0 have a value? Finn says yes. Samantha says yes before the decimal point. Hey, Samantha, you know you're in farmer though. Look what you give it. Sure. Jaja. All right, let us see what the others have to say. Amelia says yes, 0 have a value. Yes. Akila, I like you. Yes, Akila. 0 does not have a value. Natalia, the leader, where are the no's? Who says no, 0 doesn't have a value? Yes, it does. As here says, yes, it does. But 0 is nothing. 0 is nothing, you know. So how come 0 have a yes, a be a yes, a place value. Yes, no. Yes, Dominic, yeah, man. Yes, Dominic, like that. No, 0 don't have no value. Good. Depends on where it falls. Latisha, all because you did in my class last year, you come and inform. 0 is a placeholder. As here, yes, 0 is a placeholder as well. Yes, 0 does have a value. Its value is nothing more than nothing or none, meaning it represents the absence of quantity. Shania, start talk some high level maths, you know. Hello, minus stress out people them in my class, you know. All right, I got enough responses. All right. So the big question is then, does 0 have a value? Well, I am not going to answer you. I am not going to answer you and tell you if 0 have a value. You are going to confirm. And I'm going to confuse the hell out of you. Watch me, are you? Ready? Let's go. So I see a bunch of people in the comments saying what? 0 have a value. And I only had a few persons say 0 doesn't have a value. And then Shania come with her perplex yourself, say 0 this and all sort of something. Okay. Answer me then. For the persons who said 0 does not have a value, me and you tonight, how much money this? $1,000. Not you. I just say 0 not a value. Even on TikTok, they're saying that 0 has a value. It is a whole number. All right, so some persons are saying that 0 have a value. All right, so if 0 doesn't have a value, that means if 0 doesn't have a value, that means when you remove it from the number should remain the same. Not true? Think about it. If you have somebody in your life that is of no value, and them say, you know what, I'm leaving a life. I'm done with you. I'm out of your life. I hate you. I don't want to have anything to do with you. Your life should not go down if that person does not have a value. For example, let's say you're a married woman and you have your husband, and your husband work, and your husband is the breadwinner, right? He's the one that brings in the finances, pays the bills, all that stuff. If you get divorced, God forbid, you get divorced, and he was, or he had a value in the relationship, or he was significant, then it simply means that when he's gone, things might decline a little bit. Maybe not worse, but not as good as it was before, right? So if something has a value, there's no way when you remove it, the number should go down if it doesn't have a value. So then if you rub off that 0 here, how did the 1,000 become 100? How did the 100 become what? 10. And how did the 10 becomes what? 1. So essentially then, in this particular example, the zeros are said to be significant. All right? So the zeros are said to be significant, or better yet, 0 is said to have a value. All right. Now, establish that. Not true? Let us look at this then. This is not money. This is just a number. What number is this? I'm going to assume that you guys are going to agree with me that this number is 0.1. Not true? Everybody agree, say it's 0.1? We just want to hear one person through the microphone say yes. Everybody agree that this is number is 0.1?
Yes, sir.
Yes, sir.
All right. Good. Keep your microphones open. What number is this?
One cent.
Well, it's not money, it's just 0.1. What number is this? 0.1. What number is this?
Still 0.1.
Still 0.1. All right, let's continue. Tell me when you're tired. What number is this? 0.1. So what is happening? It seems as if these zeros seems to be insignificant. Not true? Because I'm adding more of them and the numbers remaining the same. It's like adding a bunch of irrelevant people in your life and your life not improving. Not true? So these zeros are said to be significant, right? All right. Let's look at another example then, right? I want you to get the point, A lot of persons just, they know how to round off numbers to significant figures, but they don't intuitively understand what it means to round off. Okay, so let's look at this number. We have this number right here. We have 1001. Look at these zeros. Do you think if I remove one of those zeros, will the number remain the same or will the number go down? Answers. If I remove one of those zeros, will the number remain the same or will the number decrease in value?
Decrease.
It's going to decrease, not true? Lovely, Abigail. Therefore, if I remove a zero from a number and the number goes down, it simply means that the number or the zeros is what? Significant. So, do you then notice now? Let me zoom out a little bit, guys. Do you then notice now? Look at those three numbers now. We have 1000, we have 0.1, and we have 1001. Do you then realize that those zeros have specific positions? The first one, it came after a number that's not a zero. The second one are zeros that came before a number that's not a zero. And then the third one, the zeros came in between two numbers that is not a zero. So what is our conclusion then? Our conclusion is that what? Zero or zeros have a value depending on its position. So for the persons who said yes, you're partially correct. For the persons who said no, you are partially correct. The only person in the comment that was actually right was Latisha. Latisha said, depending on its position. And Shania, I think you might have been right as well with that complicated answer. You almost stressed me out a while ago. But anyways, cool. So what is our answer, ladies and gentlemen? In the future, if somebody asks if zero have a value, you're not going to say yes. You're not going to say no. Your answer is going to be zero can or cannot have a value depending on its position. All right? Before I move on to the example, let's check the chat. Where are the reaction icons? Understood? Haley, Ariana, Samantha, Levan. Yep. All right. Thumbs up when I'm there. 44 are we? I should be seeing 44 fingers, hearts, and faces going up. Yeah. Fantastico. Excelente. Beautiful. Nice. Oh, Chelsea, I'm so sorry. I'm just in your comment. Chelsea is also right. She said it just depends on where it's placed. The zero shows the place value of a number. Yes, partially that is also right. Right? All right, good. Alia, what is wrong? Why is your face looking like that? All right then. So we are almost at the end of the class, but we agree. So we're going to go a little bit past 8:30 because we had some glitches earlier. Yes? All right. So let's do some rounding off then. Not true? Let's get into it. So you did some calculation. You added something, multiplied something, divided something. I don't know. You did something, right? And the number came out to be 324 point. Let me zoom up. I don't know. I think I want this to be bigger. Okay, beautiful. Nice. Zoom up, zoom up, zoom up. Okay, lovely. Nice. All right, so you did some calculation, right? Right? For now, we're just saying that we did some calculation, and the result came out to be 324.9214. All right? And you're asked to round this off to 3 SF. All right? 3 SF. So the question then is, oh, and I need to mention, as long as the number is greater than 0, it has a value. I don't think I had to mention that, right? I'm assuming that you guys must know, say, if the number bigger than 0, it has to have a value. All right, so assuming that you guys know that, right? Assuming that you guys know that, let's get into it. So question is, which digit holds the third significant position in this number? I'm going to guess that you guys say 4. So I'm going to draw the line right there. All right, I'm not able to see the chat right now, but I'm going to assume that you guys agree with me that 4 holds the third significant position. Let's check. Beautiful. That digit now is 9, and 9 is greater than 5, so we're going to increase 324 by 1. Our answer is going to be 325. All right, and that is your 3 significant digits. Okay, that's your answer. All right, another example. Okay, I thought I heard somebody. All right, another example. Let's say we end up with 11.925, and we want to round this off to 4 SF. Sir, but you said earlier that you're never going to give us rounding off to more than 3 or 2. I did say that when it's decimal places, but when it's significant figures, it can be up to 5. It just depends on what the question requires, okay? But for decimal places, we're never going to need more than 2, at most 3 digits behind the point, all right? So therefore, then let's get into it. Which digit holds the 4th significant position in this number?
2.
Very good. 2. Very good. 2. So therefore, then draw the line here. Why is this looking like this? It's not looking too tidy. Okay, very good. So draw the line here. Check. 5. We know, say, if a 5, you are treated as if it was greater than 5, right? So you're going to increase, once again, 92 to 93. So you're going to have 11.93. And there you have it. Your 4 significant figure, right? We have 11.93. Those are the 4 digits that is of significance to us. All right? Lovely. And then now, we're going to continue again. We're going to look at this now. Let's have a look at this one. 0.000825. And I want to round this off to, guess what? We're going to round this one off to 1 SF. I only want to see 1 significant digit in my answer. Right now, me ask about 4. So the question is, what's my first significant figure? Many students in the past, right now in the present, and also in the future, they would have said, sir, 0. Forgetting completely that we just had an elaborated conversation about 0 being significant or insignificant. So there's no way you can actually. Yes, you can. Yes, you can. All right, so there's no way that after that healthy discussion that we had, there is no way you can actually say that 0 is significant. Because we just established that if the 0 or zeros appear before a number that's not a 0, they are insignificant. So therefore, your first significant value would have been 8. So that draw the line right here. Check the digit that comes after. In this example, it so happens that the digit that comes after is less than what? 5. Therefore, we are going to ignore the 1, the 2, and the 5. Now, even though we ignore the 1, the 2, and the 5, and even though, ladies and gentlemen, watch this now, and even though the zeros are insignificant in the counting process, they are insignificant. But when you're writing back your answer, you have to write them back because it's 0.0008. So I'm confused. Why we are write them back if they're insignificant? Because remember, say there's no way you can have a number like 0.0008, and when you approximate it, you end up with a big number like 8. You know how small 0.0008 is? 0.008, is 8 divided by 10,000, Imagine you have $8 and you divide it among 10,000 people. Do you know how small of a quantity each person is going to get? So 0.0008 is a really, really small number. So when you approximate it, how you end up with 8? So that emphasizes the fact that if anybody in here make a mistake and write down 8 and decides, oh, I'm not writing back down the 0 because the zeros are insignificant, you're going to get a big X. All right? Because obviously, once you approximate or round off a number, it has to be close to its original value. All right? Let me see the chat. Everybody understands? Does that make sense to everybody? Where are the thumbs up? Wanna stop playing with me? Oh, okay. I need to see more. Where are the thumbs up? 44 of us is in here, or 39. All right, let me give you guys a thumbs up because it's like on a stingy. So let me give you one day. Yeah. Lovely.
Sir Pierce.
Nice. Fantastical. All right. Yes, go ahead. Question.
Yes, sir.
Yes, dear. Go ahead.
I round it off to 0.8. I don't know why the 0 zeros or the 3 zeros are there still. I just round it off at 0.
Oh, you don't know? Because they were initially a part of the number.
Really?
They were initially a part of the number. Remember, say if you're right, 0.8, Remember, say the original number there was 8 divided by what? 10,000. Not true?
Right.
Because there's 4 zeros before the 8 initially, and there's 4 zeros in 10,000. So that was the original number. When you round it off and write down 0.8, you would have essentially said that it rounded up to 8 divided by 10. You would have chopped off too much of the zeros.
I get what you're saying. Oh.
So it's too far. It's too far.
Yeah.
So you have to, even though they are insignificant in terms of the rounding off process, when you do your rounding off, you have to write back your digits there. Because essentially the rounding off, is to decide whether you want to change 8 to 9 or you want to keep 8 as 8. That's the purpose of the rounding off, Rounding off doesn't mean delete, Rounding off means take off excessive digits. But it doesn't mean removing digits from the number. It just means ignore or keep remain. Make sense?
Yeah, it does. It does.
All right, fantastic. Lovely. All right, ladies and gentlemen. So essentially, you would have gotten a basic idea of what the rounding off process is. All right, one more example before we get out of here. All right, I know you guys are tired, so am I, but we want to make sure so we finish the objective. So look at this now. We have 0. Watch this now, Tricky one, Here we go. 0.05. Come on. 0.05. All right, so why are you behaving like this now? All right, very good. So 0.05081. And we want to round this number off. Watch now, Watch now, We want to round this number off to 2SF. Haha. So the question then is, which digit holds the second significant position? Going once, microphone. Going twice. Going
So
3
the
times.
0 between the 5 and the 8?
Very good. This 0 is significant. Why is it significant and why is the other one not? Well, these zeros appear before the 5. So basically they're irrelevant in terms of the counting or the rounding process. But this 0 comes after the 5. So if I add more zeros here, the number is still going to remain as 0.05081. If I remove that 0 from this number, then this number gets larger. Then, sir, how if you remove something and it get larger? All right, let's not talk about that tonight. I'm not brain tired, so we're not going to really talk about all of that extra stuff. Just know, say me tell you, say it'll get larger. All right? So anyways, boom, here, 8. 8 is what? Greater than 5, so we're going to increase 50 to what? 51. But that no means you're going to remove them 2 zeros here. You're going to write them back. So the answer is going to be 0.051. Okay? And that pretty much gives you a basic idea of the rounding off process. All right? There is absolutely no question that exists out there that you will not be able to round off. All right? There's no twist. Maybe there's a twist with the 9, but I gave you an example earlier with the 9 where if you add 1 to 9, you get 10. You just, instead of rounding off the digit, you just round off the number before. So you just have to look out for that. All right? All right, ladies and gentlemen, I believe that is the wrap for tonight for our fundamentals. Let me see some thumbs up in the chat for the last time. All right. We're good to go. Assuming this was a productive class. Wonderful, fantastico. So with that said, you have come to the end of your session. You have yourselves a wonderful, peaceful, productive, and safe rest of weekend. And I'll see you guys next week. Please look out for the recording over the course of the weekend into tomorrow. Tomorrow into the course of the weekend. All right? Have a good night. Be safe. Good night. Bye-bye.
Thank you, sir.
Sir.
Right. Good night, everybody.
Good night, sir.